So what is a quadratic? Well, a quadratic is a function that has its highest exponent of x is going to be 2. Or it's often written as ax squared plus bx plus c. Okay, so that's a quadratic. Last year you spent 3 units talking about linear equations, right? mx plus b? Yeah, like until you couldn't see another line again. So we're going to do the same thing with quadratics. Yeah, it's going to be great. So another word for quadratic, the actual graph, the shape of it is called a parabola. Yeah, a parabola. So a parabola is the graph, is a quadratic. They're interchangeable. So quadratics form a parabola. That's the name of the graph. Essentially, parabolas, quadratics, same thing. Okay? Funny word, parabola. But yeah, that's it. So graph is a parabola, has a line of symmetry that goes through it, so it's symmetrical. Okay. We have the point that's going to be the minimum or the maximum. We call that the vertex. Okay, so your min or max point, depending on if it's a smiley face, so you can have it opening down, right? Then it's going to have, that would be a max, or it can open up. Oops, what happened to my eyes? There you go. Okay, it can open up. So it can open up, or it can open down. And so the vertex will be a minimum if it opens up. It'll be a max if it opens down. 10 times. Okay, examples of equations that are quadratics. So what do all of these have in common here? The biggest exponent is on x is a 2. Okay, an x squared. Non-examples. Why is this first one not a quadratic? The highest exponent is a 3. That's actually called a cubic, which you'll learn about in Math 30 more. Why is y equals, this is negative 1 over x squared, not a quadratic? Do you remember your exponent laws from Math 10, roots and powers? Long time ago. How can I bring x squared to the numerator? What happens to the exponent? You're thinking of fractional exponents. Negative, oh, I just said it. It becomes a negative, right? Negative exponents will move it from the numerator to the denominator or vice versa. So to move this up to the numerator, it actually is a negative exponent. Remember that? So that's not a quadratic because the power of x is actually negative 2, not 2. It's also called a rational equation. Why not for the next one? Because of the square root, yeah. And last one, what's this, or second last one was, yeah. Anyways, I can't speak by block 4. Y equals x plus 3 is what type of graph? Line. It's linear, right? Highest degree is 1. So back in the day, you've learned a term. What is a set of ordered pairs? What do we call that? It might be a tough one. That's the R, then an E, and an L. A relation. So whenever we relate x and y together, right? It's a set of ordered pairs. It forms a set of ordered pairs. It's a relation. What is the definition, or the word for this definition? The set of all x values for which a relation is defined. The set of all x values.
Domain.
Domain. Ding, 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 ding. Then range, a set of all y values for a given relation. A rule that assigns to each element in the domain a single element in the range. Or another way to say that each x has only one y. What type of relation would that be? That's, where is your brain going? You can't. You can't spell a function without fun. You guys. A polynomial function of degree 2. It's called it's also called a parabola. That's called a quadratic. And last, uses f of x to represent the y variable. So function values are y values. That might be hard. Functional notation. Or function notation. All right, all of this here, I just wanted to throw on the front page, but we're going to talk about in depth over the next like 3 or 4 classes. So it might be a lot right now, but I just wanted to have it there. There's 2 ways we can write our equations. One of them is vertex form. This is on your formula sheet. Okay. We'll talk about what those variables A, P, and Q stand for. And I might come back to this. Yeah, let's come back to this later, when it actually means something to you. Okay. All right, so again, our equation can be written in standard form or in vertex form. So there's 2 forms we can write our equations. I feel like I should make this bigger. So let's grab your graphing calculators. We're going to review some stuff about how to punch this all into your calculator. It doesn't matter. It doesn't make a difference if you are or you aren't. The only time it makes a difference is if we push the sine, cos, and tan buttons. It's the only thing it affects. Okay, y equals. Okay, so that is in the top left. Y equals. Woo! Where'd I go? There it is. Okay, is everyone there?
Yeah.
Y equals. What do you not have you found it? Good? Okay, so it should look like this. We're all good now. Type in your function. -2 x squared plus 1, 2x plus 2, 3. Sure, let's graph it. Yes. So, as most of you should have standard, like this is what you see, right? Okay, so type it in 1 second. And then we push graph. Okay, so what do we do? What do you see? We don't see the whole graph, right? We want to zoom out. There's 2 ways, though. I don't like the zoom out button. I feel like it's just the cheap way to get to where you want quickly, which is great sometimes, but sometimes it's not. And in this graph, all I need to do is go what direction? Up. I just need to go higher. I need to see higher up. So let's just change our y maximum. Okay? So let's go to Windows. And we're going to change our y max. How high do we want to try? 18. Okay, I'm going to try 18. See what happens. Is it high enough? Nope. So push window again. 100. Sorry. Graph it. Too big. Yeah, kind of too big. Let's go back. 50. We just need half of it. Okay, so I'm going to go to Windows. What do you mean? You can bring it here.
50 is yes.
Then we changed our y max. We made it 50, and let's change our scale to maybe 5 for y.
Oh, we're doing like maximum.
You paused it. You pushed enter. You need to unpause it by pushing enter again. Yeah. Okay, so where were we? This is why it takes. Okay, so scale. I'm going to change my y scale. Doesn't that look beautiful? If you zoom out, yours is not going to look as nice as that. It's beautiful. You can use the zoom feature, so zoom 3 and then enter to zoom out, and you keep pushing enter the more you need to zoom out. All right. So there's our beautiful graph. When we write scale on a test, you'll often see it written like this, the windows, I mean, right? So the windows, we would write the min value, the max, and then the scale. Do you remember this? X min, X max, and scale. So our why would I need scale? Like just to show, like if I wanted you to graph it a certain way, I would put this in. Because the problem with scale is if I had y or scale here of 1, what that's saying is because there's from negative to 10 to 50, that's 60 ticks that I'm trying to put in my graphic calculator. And so 60 ticks, that's why you can't really see it, right? So by changing our scale, it's easier to read the graph a little bit. So now we know each one of those ticks for y stands for 5 units, right? And I have a better idea now what my y-intercept is, because it's going to be between 20 and 25, closer to 25. Our y-intercept is going to happen in there. Because I know my scale, I can kind of interpret my graph better. All right, we went negative 10 to 50 and a scale of 5. Thank you. Okay, what is the value of y at x equals 0? You can use your table. I feel like there's an easier way. How do we get to our table? Let's just start there. Second graph. Yeah, our second table. Second, then the graph button, and that will bring you to, and so when x is 0, y is 23. Going back to your graph, I feel like there's an easier way. So the first way was second graph, right? The other way is the trace button. We push trace, then the number we want for x, and enter. So where are you? Trace, just the trace. 0, enter, and there it is. If I want what is y when x is 1, trace 1, enter. And once you're on that, I could just keep putting in x values. 6, enter. 2, enter. 5, enter. Whoa, that's crazy. There you go. 3, enter. So that's cool. I like the trace feature. So 0, enter, it's 23. Yeah, there's a Casio out there, right? I think somebody has a Casio. Different brand of calculator. They're on their own. Or bring in your manual. That's what I always say. What is the value of x at y equals 0? So there's two methods here. Catalog? Oh, what is the catalog? Oh, the catalog tells you it has every single function in the calculator. It's like the glossary or something, I don't know, or index. Yeah, like so it has every possible thing that's on this calculator is in the catalog. But a lot of these you don't use. Like, yeah. Okay. Doesn't matter. Doesn't matter. You don't need the catalog. So let's talk about when you know your y value and you want your x. That's a little tougher. Does anyone have any ideas of how I could find my y-intercept on my graphing calculator? Table, sometimes that'll work. If it works out to be a decimal, it won't. Okay, here's my two methods. Sorry, not my y-intercept, my x-intercept. If I want to know my x-intercepts, one option is second trace. So second trace number, anyone remember? Yeah, 2 for zeros. Okay, zeros is another word for x-intercepts, or 0. Now, the problem is it tells you left bound and right bound. So what it's asking is, can you please move your cursor to show me between what two values I'm actually calculating the x-intercept? Yeah? Oh, yeah. Okay, so what we want to do is move the cursor to the left or below. So we're going to go on one side of the x-intercept that we're finding. So we know I'm on the left side here. You can't really see it because my y value is negative. So I'm going to push enter. And a little arrow should pop up at the top. Okay? And then it says right bound. So now we have to cross the x-intercept and go on the other side of it. So this is the right side of the x-intercept. And you push enter again. And what this does is it says it tells your graphic calculator, can you please find the x-intercept between these two values? That's why we have to go left bound and right bound, because there's more than one. You have to tell the calculator which one. And then your guess, you can move closer or you could just push enter. It doesn't really matter. And there it is, negative 1.53.
Mine said no sign, no sign.
Okay, so that happens if you do your left and right's opposite, usually. So if you actually did the right side is the left, right, then it's confused. So left side, below, and then above. Second trace 2. Yeah, second trace 2. Let me just, one second. So let's try another one. Second trace. Okay, number 2. We want to find the other one. So we're going to go to the other side. Now I need to go on the left side. So the left side of this point, is that above or below? Above, right? This would be the left side. Left, right, if you forget. L for left, check mark for right. Used to always use that back in the day. And then right side is below. I can't really see it, but that's okay. I know I'm below because my y is a negative, and I'm going to push enter. Okay, and then we push enter again. The gas doesn't really matter. You can scroll back up if you want, but it doesn't matter. 7.53. Uh-oh, what was the first one? 5.2? Okay. The other method you could use, which your teacher might have showed you, I don't know, is to make your y2 equal to 0. Okay. So if you want another way to find your x-intercepts, you make y2 equal to 0. And then we're going to find the intersection. So second trace 5 for intersect. I don't know if you've ever done this. My rating status in it. So what we're going to do is y2 equals 0, second trace 5 for intersect. So second trace 5 for intersection. All I have to do is scroll to the one I want and then push enter 3 times. 1, 2, 3. Nothing fancy. You don't have to worry about left bound, right bound with this method. Okay. So scroll over to the one you want and then push enter 3 times. So for example, if I want to find the other one now, second trace 5 for intersection. Scroll all the way over. Whee! Enter, enter, enter. What? Yep. Okay. Whatever method you like, you can use. I don't know. So in this first method, you had to do the left bound, right, and the right bound. And then guess. Like, man, I don't know why I can't write today.
How do you know where to guess?
It doesn't matter. The guess doesn't matter. You can just push enter. So wherever you left off, just push enter again. You could just go left bound, right bound, enter.
Like he means like where on the thing.
Yeah, like, yeah, your guess is really just, that's a good question. So when you're actually doing zeros, the guess is actually the x-intercept. Like you're trying to get as close to that x-intercept as possible. Well, it's as close as you can get. So like here would be like there. That would be a guess. All right, next question. What is the highest point on my graph? How do we, what is that called? Max. Yeah. Does this graph have a max? Yep. It opens down. Second trace number 4. Guess what comes up? Left bound. So we have to go left of the maximum. So that means left side of the vertex. Enter. Scroll. I don't know. Enter, right bound, and then it says guess. Guess what? If I don't put, like, it just helps your calculator to go, okay, I'm telling you it's around this area, but it doesn't make a difference. And then you should get, now some of you get 3.000001? Yeah. Essentially, it's your calculator is doing a calculation, and so, but notice we're all really close to what number? 3 and 40, 3 comma 41. So I would just probably say to the nearest whole number or nearest 10. Okay, so what is the highest point? That's the maximum. We find that going second trace. What number was max? 3 or 4? Then left, bound, right, guess, enter. Yeah, in this case, it would be where your vertex is. The highest, right, that highest point. The guess is always what you're trying to find, like putting the cursor to where you want. Okay, last. Go to Y2. Y equals Y2. I know, isn't this fun? 3x plus 6. Okay, graph it. Should look like that. How am I going to find the intersection point? Yeah, second trace. 5. We scroll to the one we want because there's 2 intersection points. And then just push enter 3 times. 1, 2, 3. So negative 1.4, 1.7 is 1. And okay. And then find the other intersection point. Type that in. Okay, so I like getting this calculator stuff out of the way at the beginning of the unit so that if you're answering questions that you can actually, if you want, you can look it on your graph it on your calculator, and then that can help you. And also, I hate going through it. Some of you remember all the features, some of you don't. Okay, so what did you get for your other point? 5.9? Thank you. Beautiful. Alrighty. Oh. Let's look at the investigation. Yeah, let's do it. But I'm gonna walk through this fairly quickly. Okay? So I think what I'm gonna do is what I'd like you to do is grab your graphing calculators. You're gonna need those. Okay? Go to y equals and clear everything that's in there. Okay? Type in x squared. And what I want you to do is we're going to make it bold. Does anyone know how to make a bold line? Yeah. You move all the way to the left so that little line is flashing. And you push enter once. That's going to make it bold. Fancy. Oh, you don't worry your pretty little head because you have a colored calculator. So you can tell the difference between your two lines quite easily. You're so lucky. The rest of us need to bold our lines so we can tell the difference. Blue and red and sorry. Okay, so there it is. Can we change our windows?
How you did that?
How did I do what? Okay, can you all go zoom number 6? So if we want to reset our windows, zoom 6. Okay, so which part? The zoom?
Yeah.
Zoom and then number 6. It's your standard. So if you want to reset your windows to back to standard view, zoom 6. Okay, there's our y equals x squared. So let's type in y equals x squared plus 2. Graph. You're just going to do the first one, just the one. Okay. What does it look like? What does it look like is happening here? You went up by 2, and that's exactly what's happening. Okay. So this x squared graph, right? If you actually look at a table of values of y equals x squared, if you had -2, -1, 0, 1, and 2. When you square -2, what happens to it? What does it become? +4. Okay, there it is, +4. -1 squared is +1. 0 squared, 0. 1 squared, 1. And 2 squared is 4. And so the reason why that's not right. So that's why we have this axis of symmetry is because when we square a negative, it comes out as positive, right? So x squared plus 2, we could just take these points and shift it up 2. Up 2, up 2, and up 2. Let me zoom in a bit. Okay, so we're just 2 up from the other. So the same x, well, the x values stay the same. We just go 2 up, 2 up, 2 up, 2 up. And that would be the graph y equals x squared plus 2. So in this equation, this vertex form, what letter do you think we're changing? P, Q, or A? Q. You're right. So we are working with plus Q. So the Q of the graph is what we call, it's going to be the vertical shift or vertical translation. So it moves the graph up or down. So the Q value is the vertical translation or shift, where it moves the graph up or down. also is one more thing. And I'll let you copy that down first. So the other thing it is it's the y coordinate of the vertex. So notice, what is the vertex? I'll let you write that down. Oh wait, I'm talking too fast. I'm trying to rush. I'm sorry. As much as we can. And 2 more pages. Yeah, we'll see. Yeah, okay, so let's not waste our time. So notice that the vertex here of this green graph is 0, 2. I don't know if you can read that. Probably not. Yeah, so let me just move it. I lost a point, but that's okay. Okay, so 0, 2 was the vertex. So just really quickly, what do you think x squared minus 3 will look like? 3 lower. Beautiful. 3 lower, 3 lower. Okay. Now notice that the shape is the same. We're not changing the shape. We're just vertically moving it. And so it's going to still follow that same pattern of, here's my vertex, and so 1 over is going to be 1 up because 1 squared is 1. 2 over is going to be 4 up because 2 squared is 4. It still has that same shape. What you'll notice is 3 less than this, right? We moved it 3 lower. There's 3 lower. But that shape of the quadratic shape of following this pattern, it still follows that pattern. 1 squared is 1. 2 squared is 4. 3 squared would be 9 up from that point, from that vertex. Okay, good times. Let's move on.
Does that mean they'll never touch because it's exactly the same?
Yes, they won't. You're right. They're parallel to each other in a weird way because by definition parallel, they never touch. Yeah, because of the same shape. Sketch the following function. Okay, what variable do you think, if we're comparing it to vertex form up above, which variable are we looking at here? Sorry. P. Okay, we're going to look at P. What does P do to the graph? It's going to move it. Let's take a look. So go back to your graph. Clear this y2. We're going to leave x squared. Here we're going to type in x minus 2 squared. Oh, shoot. I hate when I do that. There you go. Okay. Got it? Good. What way did it move? The other way. It moved what direction? To the left or to the right? To the right. Okay, this moved. Did that like blow your mind? Maybe, but remember that equation is x minus p. So what's your p value? It's just positive 2 because the formula is x minus p. And so p is actually, it's going to be the opposite sign because the minus sign in the formula. And so that moves it 2 to the right. Oh, that's not right. Clearly I should know my lefts and my rights. 1, 1, then 2 over 4 up, 2 over 4 up. So again, same shape. That just, it's called a horizontal translation. Moves the graph left and right, left or right. And what's the okay, I'll wait. Slow down. Sorry, there's just so much I want to get to. What's the vertex of this new graph? 2, 0. So notice that was our p-value. P was 2. Okay, so notice that's going to be the x-coordinate coordinate of the vertex. Okay, so let's take a wild guess. If x minus 2 moved it 2 right, x plus 3 is going to move it 3 left. And the reason why is if the formula is a minus, in order to make a plus, you have to subtract, right? A plus happens when you subtract a negative. So would you agree that x minus negative 3 is the same thing as x plus 3?
Yes.
Yeah. And so my p-value is negative 3. My p-value is negative 3. And so we'd expect to see our vertex where? Negative 3 and 0. And then it's going to follow the same shape. So 1 to the right, 1 up. 2 to the right, now 4 up, because we square it. It has that x squared shape. Fun times. Okay. So let's just quickly predict my vertex here. What would be the vertex of this guy? The vertex. So what's the p-value and what's the q-value? What would be the p-value for this first equation? 2, yeah, because it's opposite sign. And what's the q-value? 3, so the coordinate would be 2, 3. And we're comparing it to the equation a times x minus p squared plus q. I wonder if I can change color? Yeah, change color? Yeah. That sort of did what I wanted. Okay. It's like Christmas. Brown and green. Brown. Yeah. Okay. Okay, so this next guy, what's the vertex going to be at? What's the p-value? So x is always the opposite sign. So it would be negative 1 and negative. The q is the same as what you see because the formula is plus q. So it's just the x coordinate that switches signs. That would be the vertex. So if we wanted to plot these, the first one would have a vertex of 2 and 3. And did the shape change? No, because we didn't change the a value. So the a value is what's going to change the shape. Okay, and we didn't change the a. So it still follow that same pattern of 1 over 1 up, 2 over 4 up. 1, 2, 3, 4. 1, 1, 2, 4, and so forth. So there's one of them if you wanted to draw it. Okay, it's going to have the same shape. It's just translated or shifted. Okay. So A. I only graphed one of them. You could do the other one if you want. Let's move on. Let's just look at these two. Graphing calculator. So A, this is the A in the y equals ax squared, x minus p squared plus q. And A changes the shape. So this is what we call a vertical stretch. Because it's going to make the graph more narrow or wider. Okay. So you know what we're going to do? Yeah, we're just going to do this. Okay, y equals 2x squared. When you graph it, is it going to be more narrow or wider? So go to y2, clear y2, 2x squared. You could just watch, actually. Or you could graph it if you want. Okay? So here, does it make it more narrow or more wide?
Narrow.
Narrow. And the reason why is all our y values, if we go to the table and I look at the table, what's happening to all our y values? It was 1 before, now it's 2. It was 4 before, now it's 8. 9 is 16. They're all doubling. So that a value is doubling because it's 2x squared. It's actually doubling all our y values. So our graph, when you double 0, it's still 0. So it doesn't change the vertex. But 1 becomes 2. When we were 4, it became 8. And so it became more narrow. Okay? So 2x squared. So what do you think 1/2 x squared is going to do to our y values? Oh, sorry. Is that better? Okay. So what do you think y equals 1/2 x squared is going to do to our y values? Half them. So a 1 becomes 0.5. Half of 0 is still 0. The vertex doesn't change. Where it was 4 before, this was 4, is now going to become 2. It's going to be half the size. This was 4, this is now 2. If it was 9, it's 4.5. Right? So it's going to become wider. Less deep in a way. Okay? That's the 1/2. Okay, so turn the page really quickly. Can you fill in same thing for x on all 3 of these? So without a graphing calculator, we're going to fill this in. All the x values are the same. -3 to 3. All the way from -3 to 3. Okay, fill in your y's. So what's -3 squared? 9. -2 squared would be 4. 1. 0. Here's the cool thing. It's going to be reflected, right? There's an axis of symmetry. 1 squared is 1, 4, and then 9, right? It has that mirrored property. So without just using this table, what's going to be the y value for y equals 2x squared? 18. And then it's double the previous y value, right? We're doubling our y value. 2, 0 doubled is 0, 2, 8, and 18. So what's my y value? What's 3 times -3 squared? 27. It's 3 times my original y value. Okay, what about the next one? 12. 4 times 3. Next one? 1 times 3. Oh my. Okay, we're going to skip graphing it. I just more wanted to look at the y values. Oh, sorry. Oh, sorry. We're getting there, I promise. We are getting there. So the next thing, we're almost done. We're actually going to skip the last graph. We're just going to look at this one. What happens if our a value is less than 0? Oh my gosh, what do we do? Look at my graphs. Okay. -x squared, what happens? Boom! Look at that. Okay, that has a name. We say it's reflected in the what? X-axis. So all our y values became negative y values. So same shape. Uh-oh, I can't count. Hate when that happens, eh? Oh. So go back to grade 1, or kindergarten. Those were good days. All I had to worry about was my alphabet, counting. I know. Exactly. Okay, so we say the y became negative y. We call this a reflected in the y-axis. And so if a is greater than 0, it's going to open up. Meaning if a is positive, it opens up. If a is less than 0, it opens down. Pretty simple, okay? So we're going to turn the page when you got that down. Yeah, you're done. It's a lot, yeah. This stuff is kind of important though because you're going to spend like all the transformation stuff, the shifting and the stretches, you spend like most of the course talking about that in 3-1. So they want you to kind of get used to the terminology. Oh, the formulas? What do you mean? They're on the formula sheet, yeah. Yeah, they are on the formula sheet. Okay, so yes, this equation here is on your formula sheet. Okay? So we need to be able to interpret the equation as well as interpret a graph. Okay? What's the vertex for this first one? We're almost done. We're almost done, guys. I promise. What's the vertex? Okay, remember the vertex is always P comma Q. So let's go back. I'm going to go back to something because no one's answering. This is what happens. Okay, so remember that first page with all the definitions? Remember that? Sort of? Okay, well, vertex, the vertex coordinate is P comma Q. That's what it is. So P comma Q is the vertex. So looking at this question that we're doing right now, what's my P value? 3. P is 3. Oops, that's a highlighter. And Q is 4. So we have 3 comma 4. Okay. Will this graph open up or down? Up. Up. To get the equation of the axis of symmetry, it's always equal to x. X equals the p value. Okay, the axis of symmetry is always x equals p. So in this case, it would be x equals, what's the p value? 3. That would be the equation of the axis of symmetry. How do you find the y-intercept for any function? Okay, you use your graphing calculator, sure. Another way. So if we know, this one actually opens up, yeah. At the y-intercept is when x is equal to what? 0. So set x to 0. 2 times 0 minus 3 squared plus 4. Negative 3 squared. 9 times 2, 18 plus 4, 22. So that would be the point 0 and 22. Okay? Okay, I'm going to get you to try the next one on your own, and then we'll go through it. Okay? Try the next one on your own. X equals negative 1. X equals your p value. Okay? What did you get for your y-intercept? We just replace x with 0. Plug it in your calculator. So in your calculator, just replace x as 0. Negative 3 times 0 plus 1 squared plus 2. Oops, why did I push graph? Enter. -1. So 0 and -1. Okay, a little, does this graph have a max or a min? It's opening down. It's going to have a max if it opens down. Okay. Why is p negative? So remember, it's always the opposite sign. So notice the equation has x minus p in it, right? And now this is a plus 1. And so p had to have been a -1. Because if I sub in a -1 minus -1, that's how it became plus. Okay? This graph would be a max. And if I asked you the max value, what would be how high does this graph go? The vertex, and it would be the p value, the q value of the vertex. So it goes as high as y equals 2. Okay, because that's the vertex. That's the highest point, -1, 2. So the highest y value is 2. Okay. Okay. What would be the domain of this graph? Well, this is what we're going to do. I'd like you to all grab your textbooks. What? I'm going to start your homework with you. Okay, so your assignment, the first one is number 8, and it says find all the features. I'm going to tell you what features I want you to write. Okay. So you're not trying to make the equation. Ignore what the equation is actually asking. What we want to find is I want you to find the vertex, the direction of opening, the axis of symmetry. We're going to do it together. It's max and min. Is it a max or is it a min? And what is it? The x-intercept, the y-intercept, domain and range. Okay. So this is on what page actually is it on? Your textbook, number 8. I'm going to open it up. Number 8. Find the actual question graph. Sorry. No, it's on the website. Okay, so there's a graph there. I'll just roughly sketch it. Can I close somebody's textbook for a second? Okay, so your graph looks like number 8. The first graph. You can kind of see what it looks like. Okay? So it says determine the quadratic function in vertex 4. You don't have to do that. Okay? For number 8, for these graphs, you just are listing these things. Okay? So this graph has -1, -5, and -4. Here. And goes all the way up to 5. So this is our graph. And like this. Okay? So just by looking at this graph, what's the vertex? Okay, so x was what? -1. Y-intercept? Sine up. And up even has like a parabola in it. X is the symmetry, so that's this line here, this vertical line that goes through the vertex would be what? What does it go through? What number? Negative 3. And we would say we make it to make a vertical line equation, x equals negative 3. Okay. Max, does it have a maximum or a minimum? Min at y equals, what's the lowest y value? Negative 4. What's the x-intercept? Negative 1. So we write negative 5 and 0 and negative 1 and 0. Y-intercept? And last domain. What's the domain of this function? Anyone remember? X? An element of what?
The real.
The real. Keep it real. What I would say. Range. Y is not an element of the reals because it has a minimum. Greater than or equal to the lowest y value, negative 4. Okay? So that's what you're doing for number 8. You're listing those things. Those characteristics, you don't have to make the equation. Not so bad. And then the other stuff is numbers. No, I don't know. I'm on the wrong page. 1 to 3, A and B for all of those. 5, 10, and 12.